All right, taking a look at these next ones here. So the first thing we have to distribute is this 3. So we have a to the 9/2, b to the 2 times 3 is 6/3, over a to the 2 times 3 is 6. So let's see. Well, one thing I notice is we have a's in two spots, so we have to subtract those. So I might write this with a denominator of 2. So we have 12/2. So we could subtract. There's more on the bottom. So we have b squared. 12 minus 9 is 3. So a to the 3/2. Now this next one, let's take a look. Well, anything to the 0 power is 1. So this is 3 to the negative 2, x to the negative 2, y to the negative 4. Over, well, this is all multiplying, so negative 12, x to the 3rd, y to the negative 2. Move around some of these negatives, so we have negative 12 down here still, times 3 squared, x squared, y to the 4th, x cubed stays, y squared moves to the top. And let's see, this is a tough one without a calculator, negative 12 times 3, but you could do that. 108. X, we have x to the 5th. And well, where are there more y's? On the bottom, so we have 1 and y squared. And then this last one, once again, we have to distribute. So we have m to the negative 6 over 2, n to the negative 12 over 3, it's an n, excuse me. And this is an m, my bad. M to the negative 12 over 5, and n to the negative 18 over 4. Well, let's see, we got to make some common denominators. So this one could be 10 for our m's. So if this was 10, this would be negative 30 over 10. Divide by 5, divide by 5. If this was 10, we'd have negative 24 over 10. Let's see. So if we were to flip this, we would have m 24 over 10, m 30 over 10, because they're negatives. And what's our common denominator here? It's going to be 12. So times 4, negative 48 over 12. So we have n to the 48 over 12. This one times 3 times 3. And we have to flip it, so we have n 12. And what is 18 times 3? 24, carry the 2, 54. So now where are they going to more? There's more on the m's on the bottom and 6 more. So we have 6 over 10. And where there are more n's on the top and there's 6 more, so 6 over 12 reduces down to the 1/2 and the m to the 3/5. So now as you flip to the back page, we're going to take a look at some solving here. So we want to make our bases the same, so we add 25. So we have 5 to the 2x minus 1 equals 25, which I know is 5 squared. So 2x minus 1 equals 5 squared. Bases are the same. So 2x minus 1 equals 2. And then if we solve this, we end up with x equals 3 over 2. Now when it's our base, we need to get rid of that power. So to the negative 5/3 on each of these. And so x, we have to distribute 1 to the negative 5/3, 8 to the negative 5/3. Well, they're negative, so we flip. So this is really just 8 to the 5/3 because of 1 on the bottom, divide by 1. So 8 to the 1/3 to the 5th. So we have 2 to the 5th, which is 32. So this one, before we do that, we have to divide by 9. So x to the negative 2/3 equals 16 over 9. And now we raise it to the negative 3 over 2. And you'll probably be able to start doing these in some steps. We distribute, but we'd have to flip it. So 9 to the positive 3 over 2. 16 to the positive 3 over 2. So this is the 9 to the 1/2 cubed. 16 to the 1/2 cubed, so the square root of 9, 3 cubed is 27, 4 cubed is 64. Now the next one, this is another base one, so if we divide by 5, x to the 1/2 equals 25. Square each side, so we have x equals 25 squared. Now this one, how do we make our bases the same? Well, this is both powers of 3, so 3 squared to the 6x minus 2, 3 cubed to the 2x, but then we have to multiply. Our bases are the same, but with parentheses we multiply, so this is 12x minus 4 equals 6x. Let's see, minus 12x minus 12x, negative 4 equals negative 6x, so x equals 4/6, or 2/3. And again, how do we make our bases the same? So 2 squared to the 2x, 2 to the 5th to the 2x minus 6, and again we have to multiply, so we have 4x over here, 10x minus 30, minus 10x minus 10x, so negative 6x equals negative 30, so x equals 5. And now these last ones here, it says write as a power of 5. So a single power of 5. So let's start, we got 5 to the 2x over 5 squared times 5 to the 3rd. Well, when there's division, what do? We end up subtracting. So this is 5 to the 2x minus 2 times 5 cubed. And then when bases are the same, we add those. So 5 to the 2x plus 1. And it's a single power of 5. Same thing for this one. So 5 squared to the negative 2 times 5 to the 1/4. Well, we multiply, so 5 to the negative 4 times 5 to the 1/4. And bases are the same, so then we add. So 5 to the negative 3.75. And then this last one, let's see, 5 squared. Well, this is 5 to the 4th times 5 squared times the square root of 5, which is 5. Well, there's 5 squared 5/4, so 1 over 5 squared times 5 squared times 5. We'll divide by 5 and times 5, so 1 times 5 is 5.